Good morning, students. Today we will be discussing about forces and particularly about vectors and scalars. So, vectors are particles or objects that have magnitude and direction, whereas scalars are the objects which only have magnitude. Okay, so we can categorize objects or forces or anything in the basis of their direction and magnitude. So, if the considering thing has magnitude and direction, you can place them under the category of vectors. Okay, magnitude and direction. All others that have only magnitude can be categorized in the case of scalars. Okay, in the case of scalars, they are the particles or the objects that only have magnitude. Okay, so let's learn about what is vector and what is scalar with the help of distance and displacement. Okay, for example, when a person starts to travel from his school, he starts from a point A and he travels all the way and he moves to his school, and then after class he comes back to his place. Now let's consider what is distance is. The total path length covered by that person is known as distance. Okay, whereas when I consider displacement, I only have to consider his starting and ending point. Okay, I don't have to consider the path length. The only thing that matters is my starting and ending point. So in my displacement, I can see that my object or my person started from home, right, and then he moved all the way to the bus stop, to the bus route, then to the school, and then after that he came back to his home. In such a condition, the distance is the total path length covered, whereas the displacement is the distance between the starting point and the end point. So if the person returned to his home, I can say that his starting point and his end point coincides with each other, so therefore his displacement is 0. Okay, whereas when I consider distance, it is not 0, it is a very large value. Okay, now consider second situation. Here the person is moving from home to school through two paths. The first one, he is moving through the bus stop, then he took the bus route, and then he went to school. So his starting point is home and his ending point is school. Okay, so here the distance traveled, or I can find the value of distance by considering the whole path traveled by him, whereas displacement is the shortest distance between the two endpoints. So look at the figure. Which one is shorter, this curved path or this straight line? So here we can see that the straight line is the shortest path. So the distance without change of direction is known as displacement. Or in other words, I can call displacement as a distance in one certain direction, which means I can categorize my distance and displacement according to the concept of vectors and scalars. As I have already mentioned, vectors are quantities with magnitude and direction, whereas scalars are the quantities that only have magnitude. So now we can categorize them, right? So the distance comes under vectors, whereas displacement comes under scalars. Why is it so? Because if I have to consider distance, I have to take the whole path covered by him, which means I have to consider the whole direction of his journey. Whereas if I have to find the scalars, I only have to consider his endpoint and his endpoints. That means his starting point and his endpoint, right? Which means the displacement comes under the category of scalars, whereas the distance comes under the category of vectors. Okay, so that is the difference between a vector and a scalar. Okay, so here it is said that physical quantities that have direction are known as vectors. So we can call acceleration, force, momentum, etc. as examples of vectors, because we know that if we have to specify acceleration, we have to consider which is the direction of motion. That means the quantities that have or that give importance to direction are known as vectors. Whereas when I consider scalars, they only have size, but there is no specific direction. For example, time, mass, energy. We don't have to consider the direction. We only have to consider their size. So size of a quantity is known as its magnitude. So a vector has its magnitude and its direction, whereas a scalar only has its magnitude. Okay, so this is how I can categorize quantities under two things. They are vectors and scalars depending on their magnitude and direction. So now let's move to representation of a vector quantity. How can you represent a vector quantity? So to represent a vector, we always place an arrow above my letter. For example, if I am representing velocity by the letter V, I will keep an arrow above it. So this particular arrow shows the direction in which the vector quantity acts. Okay, the length of the arrow represents the magnitude of the vector quantity. For example, if I am representing a vector like this, okay, and let this particular arrow have 1 unit size, then I can say that this is a vector of 1 magnitude acting in that particularly specified direction. Okay, so as the force has a magnitude and a direction, we can categorize force under vector quantity, and it can be represented on a diagram by an arrow. For example, in this particular figure, we can represent a force. Okay, so please see here. This is my pin and this is my hammer, and with the help of my hammer, I am trying to make my pin to go into the wall. Okay, so which means I have to apply a force perpendicular to the pin head, which means the direction in which the force acts is this one. Okay, so this particular arrow shows the direction of the force applied. Okay, so this is how you have to represent a vector. Thank you.